So today's lesson, we're learning another way of solving a system of equations. We're going to be focusing on substitution. We might do a little bit of this other method down here known as elimination. Once again, this is all review for you guys. You've seen it before. You might not remember it real well, but you did see this in Algebra 1. And hopefully, I'd also like to get to this last question. Sometimes you use substitution, sometimes you use elimination. How do you know when to use each method to solve it? Okay, so that's the third thing we'll look at. But today I think we're going to be spending most of our time just on this thing called the substitution method. All right, substitution. We good? I printed this for you, no? You guys are good. It's at the very top, like I wrote it as a sentence though. All right, so substitution elimination are another way of solving system other than graphing, which is not very precise. These are very precise. You'll get very definite answers. They're a little bit more work, but they're more precise. Both of them involve getting rid of one of your variables, right? We have two equations with two variables. In both of these methods, we get rid of a variable somehow. So with substitution, the way you get rid of it is by replacing the variable with something else. With elimination, the way you get rid of it is by canceling it out. Okay? Different methods. We're going to start with the substitution method. So here's our steps. We're going to be using these today. I'm not going to read them all now, but I'll go through them as we do a problem. But these are the steps for substitution. All right? So let's do an example. Example number 1. Did I print this? No. No? Okay. So, and you're going to need some space for these problems. So I would maybe on another piece of paper, you can maybe try to squeeze it on the back, but your back's going to get full, I guarantee you. But somewhere, go ahead and write down number 1, and we'll give it a shot. I'm going to write this down myself as well, actually. Let me go ahead and get out of here. So it's y equals 2x.
No, equals minus 3. Wait, what? Minus 3?
The problem you guys just copied down.
Oh!
3x
Plus 2y plus
1?
Yes.
Negative 1?
No, it's 1.
Regular 1. Okay. Okay, so step 1 said identify the isolated variable. And what that means is you're going to look for the part that says y equals or x equals. Do you guys see a y equals up here? Okay, so here's step 1. Oh, I underlined too much. Y equals, there it is. You good? That's step 1. Now, you don't have to show all these steps. I'm just doing this for teaching purposes, okay? But step 1 is to identify where it says x equals or y equals, okay? Now read your step 2.
Plug what you circled into the other equation.
Oh, I didn't finish step 1, did I? So let's back up. Step 1, identify the isolated variable and what? What does it equal?
2x.
There you go. So identify the isolated variable and circle what it equals. I forgot that. My bad. All right, so step 2 was, what does step 2 say again, Henry?
Plug what you circled into the other equation. If it was y equals 2x minus 3, plug it in for y. If it was 3x,
if it was x equals, plug it in for x, right? So let me ask you, was it y equals or x equals?
Y equals.
So we're going to plug this in for what?
2x minus 3.
We're going to plug it in for y. So since it's y equals, we're plugging this in for y. And here's how I show my work. I'm going to do a different color though because I'm doing a step, right? I'm going to take this, I'm going to put it right there. This is step 2. So
you plug it in. Oh, I get it.
So I'm going to do 3x plus 2, and I'm going to replace the y with what? That's step 2. That's the magic step. If you guys get this far, you're home free. The rest of it's what we've done already in class. When I say home free, I'm assuming you got the old stuff down. But yeah, I'm going to stop here, though. I want to make sure you guys got this. So step 1, identify the isolated variable and circle what it equals. Step 2, plug it into the other equation. Good? If you get that, You've done most of the work. Now let me ask you, up here, how many different letters did we have in this equation?
2.
Down here, how many different letters? We have 1. They're both x. I got rid of one of the variables. That's the point of this method, right? So now we are going to just, what does step 3 say?
Solve the resulting equation.
Okay, so step 3 is we're going to solve it. So here we go. Hannah, you said distribute. You're right. So let's do that. We're going to distribute. We get 3x plus 4x minus 6. Now what?
And then you
Good. Now what?
Add 6 to 1. It'll be 7x equals 7. Divide by 7 and x equals 1.
There you go.
wait.
I'll wait. So step 1. I'll just kind of review while you guys are writing. But step 1, identify the isolated variable, circle what it equals. Step 2, plug that into the other equation. Step 3, solve. Okay. The hard part, though, is in step 2. I plugged this circled part in for which letter?
Y.
And I did that because it was y equals. If it was x equals, I would have plugged the circled part in for x. So you got to watch out for that step, okay? We'll do an example like that in a little bit later. Now, we're not done, though. You'll notice the steps are not complete. So what is the next step that we wrote down, say, after step 3?
Plug your answer into either original equation and solve for the other variable.
We're going to take this answer, x equals 1. I'm going to plug 1 in for x to either one of these so I can find out what y is. Huh? Say that again. This is our last step. So we have to find x and y, right? When you solve this, remember when you guys found the place where they crossed on your homework? And you wrote it as a point? How many numbers were in there? There were 2, right? So we found one of the numbers. Now we got to find the other one. We found the x, let's find the y. So step 4, I mean.
I will plug it in.
Let's do step 4. And there is a better choice. Which one would you
The
choose?
second one, because the first one is harder than the second one, because then you get y by itself with no other variable, and then you subtract it to the other side and you divide. You know what I'm talking about?
He was so confused.
I was
That's
like,
why
okay,
I
so
always
like,
I'm a visual learner, but I'm going to stop you there because I'm not sure what you said.
um,
But here's what I'm going to say.
can you put the variable? Yeah.
I like this one.
No, not that one.
Was it plus 3 or minus 3?
No. Do the other one.
Now, you don't have to go with what I like, but here's why. The one that has the y by itself, I think it's easier. I'll show you why. Why? So what does x equal?
2 minus 3.
1.
X equals 1, right?
Yeah, but 2 times 1.
What's the answer?
2.
Negative.
I think that's easier. But
Wait, let me copy.
you can plug it into the... It will work on the other one. You know why? Because it's where they cross, and they both have the same point. So it doesn't matter which one you use. You should get -1 either way. If you don't, then something's wrong. It should work for both, right? So there you guys go. There's your steps. A lot of steps.
Wait.
Sure. We're living the Vita Loca up in here. Somebody said this was crazy. So I'm just validating.
Do we have a quiz tomorrow?
No. Do you want a quiz?
No.
You guys don't have quizzes.
You give him one.
He's ready?
Asking because it's Wednesday.
He's right. I'm glad you asked, but no, there won't be.
Tomorrow.
All right. Please write down number 2. Please write down number 2. We're going to do it again. I will. Calm down. Okay, I am going to have... Would you read me the problem? There you go. Number 2. What was the numbers? I forgot.
Y equals -2x minus 11.
I think it... Let me see what you wrote down. Oh, no, the one that we just wrote down from the board. Number 2. From here.
4y minus 3x equals 2.
It was this one. Oh, let me back up. This guy. Did you write that one down yet?
Yeah.
So it's 4y minus 3x? All right, so So 4y minus 3x equals what?
2.
2. And what was this guy?
5y minus
5y.
8
Minus-
equals x.
Minus
8.
8 equals x.
Yeah.
Okay, step 1. I want you guys to do step 1. Underline and circle. So I'm going to ask Alicia, what do I underline? Where at? Here? Where? Here? Yeah. Okay. Good question. We'll get there. LaFontaine, what do I circle? Good. We circle 5y minus 8. So we find the part that says x equals, and we circle the part that says what it equals, okay? Now, step 2. Go for it. This is the hard one, so see if you guys can do it. So, Hannah, I want to plug this in somewhere, so I'm going to draw an arrow. And I want you to tell me where am I going to draw this arrow to, from the bubble to what? Well, next to the 3, right? We're going to put it there, where the x is at. So what would that be if I wrote it?
So you're gonna put
Hannah.
So you go 4y minus 3x. No, you're gonna, and then you're gonna put parentheses. You're gonna add that. The 5.
So you just rewrite this whole thing, but you take the x out and you put the circled part in.
That
That's it.
makes more sense now. I was confused the first problem.
So you guys will notice now this time, I took the x out and put the bubble where the x was. Why? Because it's x equals this time. If it's y equals, you replace the y. If it's x equals, you replace the x. Okay? All right, and now we solve. Sure. Let's. But this is a negative 3, right?
Yeah.
So it's going to be 4y what? Minus 15y, and then
make it a positive?
yes.
Yeah, that was
Now what about these two here?
-11
Uh-huh.
plus 24 equals 2. Then you subtract 24.
And what's 2 take away 24?
-24. Yeah,
And then we divide,
sir.
and we get 2. Okay, do the last step. There's one more step. Read your steps if you don't know what it is. Read your steps, see if you figure out what it is. Do that.
Plug it back. Plug this thing back in.
Word. Eric.
Oh.
How much of this you getting, son?
I don't remember.
How much? Huh? How much of this you getting?
What?
I don't know what you did.
Okay.
Wait.
Keep up with us.
What did you do for the second step? For the first one, how did you get y equals 2x?
What's the last step?
How'd you get that? The first one?
It's given. That was one of the equations they gave us. Oh yeah, so you just take one of the equations. One of the, you take one of the confusions.
Yeah.
All right,
Any of them?
let's, yeah, it doesn't matter.
Is the-
Nelson,
I mean, they both are.
what do you do? We're on the last step.
You plug the 2 into one of the y.
That's right, so you plug 2 in for y into one of these up here. Now, which one does Mr. Bailey like, Nelson? Do you remember?
Probably the top one.
Mr. Bailey likes the bottom one. Do you know why? Because that was the x equals one. Last time I picked the y equals one, right? So the one that says x equals or y equals, I like that one. But you don't have to go with the one I like. It'll work either way. So we're going to replace y with what? 2. What do you know? It's 2 also. Don't get comfortable with that. They're not always the same answer like that. It's kind of a twink-a-dink. All right. Uno más. All right. So can I clear?
Yeah.
Okay. So one more before I I want you guys to do the first 2 steps on this one, number 3. Do the first 2 steps. Go. Here's your first 2 steps. I underline y equals, right? I circle what are equals, right? And then I plug this in where? Plug it in for the y, right? So, because it's y equals, and when it's y equals, you plug it in for the y. Okay, so now I have 6x minus 2, and what goes in the parentheses now? Equals 10. And then from there, some of you guys were going ahead and solving it, which is fine. So I'll go ahead and work this through. What's 6x take away 6x?
0.
It's 0. A lot of people are putting x. It's not. Because that's like saying 1x, right? So what you do is I just cross them off. And so here's what I got. Do you guys remember what that means? That's no solution. What does that mean about these 2 lines? If I graph them, they would be parallel. They would be parallel if I graph them. They don't touch. So that's systems of equations with substitution. So we're finding the point where they cross without actually graphing them. Yay! 23 minutes. All right. This is a lot of work. So I'm not going to ask you guys to do all of these. I'm just going to have you do one of them, okay? Let's go ahead and do number 1 and try to get me a whole answer there. See if you guys can get the whole thing, x and y. Go for it. So, Adrian, what do I underline on number 1?
Y.
Good. What do I circle, Adrian? Good. Let me talk to John. I'm going to plug this in for which one? X or Y, John?
Oh, me?
Chavez. I'm going to plug this in for X or Y? For the Y. Good. And so if I do that, I will have 17 equals 2 times 4x minus 5 equals, I'm sorry, plus x. Okay, so from here I'm going to go ahead and solve it. 8x, is that minus 10? Did I write that right? Right? 8x and 1x makes 9x. Add the 10 on both sides, you get 27. Divide both sides, you get 3. All right. Next, I'm going to ask Eric, what do we do at this point, Eric? Did you finish? Huh? Okay. Let's try, see if maybe Augustine can tell us. Augustine. Sorry, not Augustine. Augustine. What do we do now, bud? Number 1. And we just found x. Plug it into one of the other equations to solve for y. Did you do that? What'd you get? Okay, so I'm going to pick this one, and I'm going to plug 3 in for x. 7. 7. All right? That's called the substitution method. All right? All right. We'll see how far we get here with the elimination method.
Wait, what? Right now?
Yeah.
What time is it?
I know, that'd be nice.
I know, please. It will be nice, and it will be nice.
You have a brain that is more done than the crackers.
We could spend the whole day tomorrow on it.
We could, huh?
Yeah, can we do it tomorrow?
Tomorrow.
Tomorrow? Like, you said no quiz. What are we gonna do tomorrow? Why can't we do it tomorrow?
Bro, this week don't go to
Yeah, so we can like do a fresh start tomorrow with elimination.
I think we will do that because I think it would be kind of overwhelming. But what I'm going to do then, instead of doing the elimination method, is I want to share with you guys how do you know when to use substitution And then there's
There's a formula. I don't remember it.
there,
I thought there was.
You're teaching us elimination?
no, we're not going to learn elimination today. So, but before we leave today, I do want you guys to be able to know when can you use substitution, and then, well, okay, well, when then where would I do the other method? Okay, even though we haven't learned it yet, at least you'll know when to use it, so we can step into that fresh tomorrow. All right, so here's the deal.
My mom put substitution.
Take a look up here and raise your hand if you tell me which problems you think work really well for substitution. Raise your hand. I'm going to go to someone. I haven't talked to Michael today. Go ahead, Michael.
The one that would probably go well with substitution would be like number 2.
Why do you think number 2 would work well?
Because it has the y equals.
There you go. Did I print this for you guys?
Yeah.
Okay, I want you guys to, right here next to this, I want you guys to put substitution. Why? Why is a substitution? And it's because of what Michael just said. Because it has a y equals. So if you see a system of equations where it has an x equals or a y equals, then that's a substitution problem. Well, I think I'll write it more generally. I'll just put if the system has a x equals or y equals, we use substitution. Right? Because, I mean, isn't that our very first step to find the y equals or x equals? So that's how you know. If it's got an x equals or y equals, then go for it. Do substitution. So I want you guys to underline that and then draw an arrow just so you guys know that we would use substitution on that one because of that. Now the other method that we're going to learn about tomorrow, the other one that we're going to learn about tomorrow is called the elimination method. Okay? The elimination method works whenever in your system of equations your x's line up, your y's line up, and the numbers line up. So take a look. Which one of these have the x's, y's, and numbers lined up? Number 1. So I want you guys to circle this. You see how the y's and x's are lined up and the numbers are lined up? That is when you're going to use the method that we'll learn tomorrow called elimination. That's an elimination question. So you use that when x's, y's, and numbers line up. Now we don't know the elimination method yet, we will, but that's how you know when to use that. When the x's line up, when the y's line up, and the numbers line up, you're going to use the elimination method. So if you have an x equals or y equals, substitution. If they're lining up, that's elimination. Now in this case, it's neither. Are my x's lined up? If they are. Are my y's lined up?
No.
No. But, so right now the answer is neither, right? I don't have x equals or y equals either, do I? Right? So there's no, it's not substitution or elimination. But Micah just said something. Can't we just rearrange things so that it works? What can I just move around here so that things work? We can move either one. I heard both answers. You can switch the 6y and the 6, or you can switch the 12 and the 8, and then your x's and y's align up. So check this out. So in that case, we have to rearrange. So I'm going to rewrite the top one like this. I'm going to put the positive 6 here and the negative 6y here. You guys got it? Are my x's lined up? Are my numbers lined up? Are my y's lined up? That would be a what now? Now it's what method? It's the elimination method, which we haven't learned, which we haven't reviewed yet. But the point is that you rearrange it. Now, can you rearrange something so that you have substitution? Yeah, just get the y by itself, or just get the x by itself. So that's how you know when to use each method. I'm not going anywhere.